In today's lesson, we are going to be introduced to integers. The first thing that you need to know when learning integers is the definition of an opposite. The opposite of a number is the same distance from 0 on a number line as the original number, but on the other side of 0. 0 is its own opposite. This is represented here on the number line, where I can tell you that -2 and 2 are opposites because they are the same distance from 0. Here 2 is 1, 2 spaces away from 0, and likewise -2 is 1, 2 spaces away from 0. 0 is neither positive nor negative. Another example of an opposite would be 5 and -5. 5 is 1, 2, 3, 4, 5 spaces from 0, and its opposite, -5, is also 1, 2, 3, 4, 5 spaces from 0. Now, whole numbers are the set of all natural numbers, which you may know as counting numbers, all of those including 0. So, your whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Now, integers are all of those numbers and their opposites. The definition says that integers are the set of all whole numbers and their opposites. So if we were to graph these integers on a number line, it would look like this. Graph each integer and its opposite. So the first example is asking me to graph 5. Well, all I have to do is locate 5 on the number line, and I know that 5 is right here. And then its opposite. Well, if 5 is 5 spaces from 0, then its opposite needs to be on the other side of 0, that same number of spaces. So if I count 1, 2, 3, 4, 5 places, then I can say that -5 is the opposite of 5. For example B, -6, I can locate -6 on the number line and graph it like so. And then -6, if I'm not sure, I can say is 1, 2, 3, 4, 5, 6 spaces from 0. So that must mean that the opposite of -6 is also 6 spaces away from 0, but on the other side of 0. So 1, 2, 3, 4, 5, 6. 6 is the opposite of -6. It's important to know that integers increase in value as you move to the right on a number line, and they decrease in value as you move to the left. Here we have a number line to help us out with this concept, but if we look at the number line, we can see that the integers increase as we go to the right and decrease as we go to the left. We might say they get more negative as we move to the left and more positive as we move to the right. -6 is less than -2 because -6 is farther to the left on the number line than -2. And 7 is greater than -4 because 7 is farther to the right on the number line than -4. So your next task is going to be writing integers in order. The directions for this example ask you to graph the integers on a number line and then write them in order from least to greatest. The direction states that we should graph them first. This will make the task of writing them in order from least to greatest much easier to visualize. So first I see -2, and I can see -2 on the number line, so I will just put a dot there. The next integer is 5. So I can put a dot at my 5. Then 4, which is right here. 1, -1, and 0. Remember, 0 is an integer. So now my task is to write the numbers in order from least to greatest. I can simply look at the dots from left to right that I graphed on the number line and write down those integers in that order. Because they are placed on the number line, I know that they're already in order. So my first integer is -2, then -1, then 0, 1, 4, and 5. Next, we have absolute value. An absolute value is the distance a number is from 0 on the number line. Now, distance can never be negative. Think about it as if you're driving in a car. If you're going forward, you're always gaining mileage on your car. But what if you drove your car in reverse? If you drove the car in reverse, would the mileage on the odometer go backwards? No, it would increase because even though you're driving the car backwards, you're still going somewhere. And so you are getting more positive. So distance, the distance you're traveling, the distance something is, you are always a positive distance away from something else. So because of this, absolute value is never negative because absolute value is the distance a number is from 0 on the number line. The symbol, and it's two very tall parallel lines, sometimes I call them absolute value sticks. They mean the absolute value of. So we read this as the absolute value of -3. So if your task was to find the absolute value of these two numbers, how would we do that? Well, we would have to find the distance that that number is from 0. So here, our first example is the absolute value of 7. So if I'm looking at a number line, I know that 7 is here, and I know that the absolute value is the distance a number is from 0. So how far is 7 from 0 on the number line? Well, that's 1, 2, 3, 4, 5, 6, 7 spaces. So the absolute value of 7 is 7. And it's positive because it's a distance. Now my next example, the absolute value of -4, I can find in the same way. I simply locate -4 on the number line, and I count how many spaces -4 is from 0. So -4 is 1, 2, 3, 4 places away from 0. So the absolute value of -4 is 4. Remember, distance can never be negative, so even though I'm finding the absolute value of -4, the absolute value is still positive. So just to finish up, here are some additional examples just to help you with your understanding in case you haven't ever worked with integers before. The first example says, graph each integer and its opposite on a number line. The first one it wants us to graph is 3. So I locate 3 on the number line, I graph it, and then I graph its opposite. Well, its opposite is the same distance from 0, but on the other side of 0. So if 3 is 1, 2, 3 spaces from 0, its opposite must be 3 spaces from 0 on the other side. So that's 1, 2, 3, -3. By now you're beginning to see a pattern and that the numbers are going to match, just they're going to be either positive if the first number is negative or negative if the first number is positive. So for part B, if we're trying to find the opposite of -4, I can simply graph -4 and I think, well, the opposite is 4. So there you have it. In the next example, it asks us to graph the integers on a number line and then write them in order from least to greatest. You might notice that this number line looks a little bit different from our other number lines. It's not going by ones this time, but instead it goes 2, 4, 6, 8, 10, -2, -4, -6, -8, -10. I've done this to show you that a number line is infinite in all directions, and something that's really special about it is we can zoom in and zoom out as much as we want, and the number line is always going to remain accurate. So for this example, we're just going to take these numbers and graph them, then write them in order from least to greatest. So for -3, I know that -3 is between -2 and -4, so I can graph it right here. Number 6 is located right here. -5, again, it's between -4 and -6, so I can graph that right there. 2 is located here. 0 and -8. Now that they are all graphed on the number line, it's easy to visualize them in order from least to greatest. So I can simply write them in order. -8, -5, -3, 0, 2, and 6. Lastly, we are asked to find each absolute value. I'm looking for the absolute value of 8 and the absolute value of -12. Remember, the absolute value is the distance a number is from 0. Again, my number line is spaced a little bit differently, but that's so I could get all the numbers to fit. And like I said, you can zoom out on the number line so you can get all the numbers that you need. So if I'm looking for the distance that 8 is from 0, well, I can look at it on a number line and say, well, that's 4 plus 4 is 8 spaces from 0. So the absolute value of 8 is 8. And then the absolute value of -12, remember, it's the distance that -12 is from 0, and distance can never be negative. So if I start at -12 and I get to 0, well, that's 4 spaces, another 4 spaces, and 4 more. And so 4, 8, 12, the absolute value of -12 is 12. There you have it.